Right now, while you're watching this, a city of over 10 million people is physically sinking into the ground, not gradually over thousands of years like geological processes normally work. Fast, measurably fast. Some parts of it are sinking at a rate of 25 centimeters per year. That's nearly 10 inches every single year. And parts of this city are already below sea level, while sitting on the coast of a rising ocean. This is Jakarta, the capital of Indonesia, one of the most densely populated urban areas on the planet, and it is disappearing. Not because of a natural disaster, not because of a sudden geological event, but because of a combination of human decisions, rapid urban growth, and a problem that was completely predictable and predicted decades ago. Scientists warned this would happen, engineers mapped it, researchers published the projections, and the city kept growing, kept sinking, and kept flooding year after year, while millions of people built their lives on ground that was slowly giving way beneath them. The situation is now so severe that the Indonesian government has decided to do something almost unprecedented in the modern world. They are moving the capital city entirely to a different island because Jakarta is considered too far gone to fully save. Let that land for a second. A nation decided it was easier to build a brand new capital city from scratch in the jungle than to stop its current capital from sinking into the sea. This is the story of how that happened and why Jakarta is not alone. Let's start with the geography, because it matters more than most people realize. Jakarta sits on the northwest coast of Java, one of the most densely populated islands on Earth. The city itself is built on low-lying coastal land, flat, deltaic terrain, crossed by 13 rivers that empty into Jakarta Bay. The baseline elevation of much of the city is already close to sea level. Some areas are only a meter or two above the waterline under normal conditions. That baseline is important because starting from that position, any sinking at all is immediately dangerous. And the sinking is real, documented, and ongoing. Satellite measurements and ground-based monitoring have tracked Jakarta's subsidence, that's the technical term for the sinking, for decades. The numbers vary by neighborhood, but the overall picture is alarming. In North Jakarta, the area closest to the bay, some zones have sunk by more than 4 meters over the past 30 years. 4 meters in 30 years. Some monitoring stations show rates of 20 to 25 centimeters of sinking per year in the worst affected areas. To visualize that, take a ruler, 25 centimeters. Now imagine the ground beneath an entire neighborhood dropping that much every year for 30 consecutive years. North Jakarta, as a result, now sits entirely below sea level in many locations. The only thing keeping it from permanently being underwater is a system of seawalls and pumping infrastructure that is itself struggling to keep up with the rate of sinking. So what is actually causing the ground to collapse? The main driver is groundwater extraction, and this is where human decisions created the crisis. Jakarta's massive and rapidly growing population, the city went from under 1 million people in the 1950s to over 10 million today, needed water, enormous amounts of water. And for decades, the cheapest and most accessible way to get that water was to drill wells and pump it directly from the aquifers beneath the city. Millions of wells, industrial wells, commercial wells, household wells, all pumping water out of the ground at a rate the aquifers could not replace. Here's what happens when you remove water from underground aquifers at scale. The soil and sediment layers that the water was filling, layers that were holding up the weight of everything above them, start to compact. They compress, they consolidate, and the ground above them sinks. This process is called land subsidence, and it happens in cities around the world when groundwater is over-extracted. But in Jakarta, the scale and speed of extraction
combined with the soft coastal geology, created one of the most extreme cases of urban subsidence ever recorded. The buildings didn't help. Jakarta grew fast and built heavy. Skyscrapers, shopping centers, hotels, highways, all of them adding weight to ground that was already compacting below. More weight pressing down on compressed sediment accelerates the sinking further. And then there's the flood problem, which isn't separate from the sinking problem. They're the same problem. As the ground sinks, the city's drainage systems, designed for a certain elevation, stop working correctly. Water that used to drain into rivers now pools because the gradient has changed. The rivers themselves, as the land around them sinks while the river bed stays relatively stable, start to overflow their banks more frequently. And then the ocean. As sea level rises globally, even a few centimeters, and the land simultaneously sinks by meters, the gap between the city and the water closes fast.
In North Jakarta, this isn't a future scenario, it's the present. During high tide and heavy rain, which happens regularly in Jakarta's wet season, the flooding in North Jakarta is not an emergency event, it's a routine condition. Streets become canals. Ground floors of buildings disappear underwater. Residents have adapted their lives around flooding as a normal part of existence. Some families have been doing this for generations. They didn't move because they have nowhere to go, no money to relocate, no option but to stay on ground that has been sinking beneath them since before they were born. There is a wall, the National Coastal Integrated Coastal Development Project, sometimes called the Giant Seawall, that has been proposed and partially planned to protect Jakarta's coast. But the project has been mired in funding problems, political disputes, and debates over whether it can even work given the rate of ongoing subsidence. Building a seawall is one thing. Building a seawall while the ground it's sitting on is sinking is something fundamentally different. And then in 2019, the Indonesian government announced something that stopped the world. They were moving the capital. President Joko Widodo announced that Indonesia's new capital would be built on the island of Borneo in the East Kalimantan province. The new city would be called Nusantara. The decision was framed around several factors: decentralizing population from Java, reducing the burden on Jakarta's infrastructure, and creating a more geographically central capital for an archipelago nation of 17,000 islands. But underneath those official reasons, the Jakarta problem was impossible to ignore. A capital city that floods regularly, that has been sinking for decades, that sits on a coast where the ocean is rising, was not a sustainable long-term seat of government. Moving the capital was, in part, an admission that the full solution to Jakarta's subsidence problem was beyond what the government could realistically achieve before the situation became critical. Construction on Nusantara began. Billions of dollars have been committed, but the project has faced its own complications, funding shortfalls, investor concerns, the sheer logistical scale of building an entirely new city in previously forested land. As of now, Nusantara is partially built, but far from complete. The government has faced questions about the timeline, the cost, and whether the move will actually solve Jakarta's underlying problems or just leave 10 million people behind in a sinking city while the government relocates. Because here is what often gets lost in the story of Nusantara. Jakarta is still there. Jakarta is still sinking, and most of its residents are not going anywhere. The people who live in North Jakarta's most flood-prone neighborhoods are largely lower-income residents who cannot afford to move. They have built their lives, their businesses, their communities, their entire social networks in a place that is demonstrably becoming uninhabitable. The government's response to their situation, beyond the seawall proposals and the capital move, has been inadequate. Some neighborhoods have been told they will eventually be cleared and demolished as the land becomes too dangerous. The
The residents of those neighborhoods have been given little in the way of concrete relocation plans or financial support. This is the human dimension of the Jakarta story that the satellite data and the subsidence measurements don't capture. Millions of people living on ground that is sinking in a city that the government is partially abandoning with nowhere obvious to go. But now the part that makes this story bigger than one city. Jakarta is the most extreme case, but it is not the only case. Cities around the world are experiencing measurable subsidence, many of them for the same reasons: over-extraction of groundwater, rapid urbanization, heavy construction on soft sediment. Mexico City, built on the drained bed of Lake Texcoco by the Aztecs and then by the Spanish, the ground beneath it is soft lacustrine clay, ancient lake sediment that has been compressing under the weight of one of the largest cities in the world for centuries. Some parts of Mexico City have sunk by 9 meters over the last 100 years. 9 meters. The city's historic center, including the famous Metropolitan Cathedral, shows visible tilting from uneven subsidence. Engineers have been fighting this for generations. Shanghai, one of China's most important economic centers, sitting on the Yangtze River Delta. Decades of industrial groundwater extraction caused significant subsidence throughout the 20th century. The city has invested heavily in switching to surface water sources and has slowed the rate of sinking dramatically, but parts of Shanghai still sit well below their original elevation.
Bangkok, the Thai capital, sits on a river delta very similar in geology to Jakarta. It has experienced significant subsidence over the past several decades, and parts of the city are now below sea level. The Thai government has implemented groundwater regulations that have reduced the rate of sinking, but the problem is ongoing.
Houston, Texas, one of the most significant subsidence cases in the United States. Decades of groundwater and oil extraction caused massive land sinking across the Houston metropolitan area throughout the 20th century. Some areas sank by more than 3 meters. The region's vulnerability to flooding, which became tragically apparent during Hurricane Harvey in 2017, is directly linked to this subsidence history.
And this is before accounting for rising sea levels. The cities sinking fastest are almost all coastal cities. The ocean is rising, slowly but measurably and consistently, due to thermal expansion of warming ocean water and the melting of glaciers and ice sheets. A city that is simultaneously sinking and facing a rising sea is caught in a compression from both directions. The margin of safety shrinks from above and below at the same time. The projections for Jakarta are sobering. At current rates, without dramatic intervention, large portions of North Jakarta could be permanently inundated within the next 20 to 30 years, not flooded during storms, permanently underwater. The kind of outcome where the question isn't whether to rebuild, it's whether to abandon. Some researchers have proposed that the global population of people living in areas at risk of flooding due to subsidence and sea level rise could reach hundreds of millions by mid-century, not displaced by conflict, not displaced by drought, displaced because the ground beneath their city fell away and the ocean moved in, and the solutions, where they exist, are expensive, slow, and politically difficult. Banning groundwater extraction requires building alternative water infrastructure. Managing urban waste requires planning restrictions that conflict with economic growth. Building coastal defenses requires funding that many affected cities in the developing world simply don't have. Jakarta is the loudest version of a problem that exists in dozens of cities on every continent, a problem created by human decisions, accelerated by climate change, and landing hardest on the people who had the least say in any of it. The ground is giving way, the ocean is moving in, and 10 million people are living in the middle of it. The sky still hides secrets, and this is just the beginning. Subscribe to Fact Harbor for more mysteries.